which is what we want to test.
So what else have we got here?
So here on the right is, these are called pressure filters. They're used to remove the moisture from a sample very quickly. And then here you have a wet magnetic separator. So this one here, we use it to remove particularly the first stage of the magnetic particles, your magnetites and your high-end ilmenites. This is something that you would see used in some of the production plants on large scale. So we can do a lot of that testing here in the lab to help with plant design.
She's all pretty upmarket, Tom, isn't it? What's this beast here?
This one here is probably one of the most up there with some of the most interesting bits of equipment we have. It's called a Nelson concentrator. It's been one of the biggest probably evolutions in gold mining in the last couple of years, is these Nelson concentrators. So instead of just using what we often refer to as one gravitational systems, so your sluice boxes and your mats, this one here uses centrifugal gravity to spin the sample to create forces that are 40, 60, 100 times gravity to separate the gold out. And so with this one here, we're starting to be able to find where the fine gold is, and we're starting to find ways and use mechanisms to extract that ultra fine gold that at the moment has been lost a lot of the time.
We lose it off, we put it off the end of our tables and it just disappears.
Yeah, so we want to work with those gold miners and go, how can we help extract that last bit of gold? And again, we're starting to find some really interesting information that will change how the West Coasters do a lot of their gold mining.
So that would be useful with beach sand recovery as well.
Particularly in the beach sand, on that fine gold.
Yep.
But you'll find it with all of the different gold miners, that there's a certain fraction that they're losing that we believe you can actually capture with doing things slightly differently.
Well, Tom, fine gold is the holy grail. It is.
So this one here is a cyclosizer. It looks like it's out of the 1960s, but it is actually brand new. This one here is, with the sieves, you can size down to 38 microns quite easily. Below that, it becomes very hard to size the sand.
Can you see 38
38
microns?
micron is starting to see the limit of what the eye can see as a single particle.
Yeah.
Where this one here, you can put the sample on the left-hand side, and it goes to what these are called cyclones, and it sizes them down to this one here, around 6 microns, which would be thinner than a human hair, is getting very, very fine.
So 6 microns we wouldn't be able to see.
Definitely not better to see. And what we can do with that is start to understand what is going on with these minerals at that size. And if you understand and can see what they're doing, then you can find ways to extract them.
I can see numerous possibilities. Gosh.
Coming around here, we have what's called a bottle roller. This one here is commonly used in the cyanide manufacturing or in the chemical extraction of some of the minerals. So it's something we're interested in, on what other methods can we use to extract some of these minerals. Because we're also looking New Zealand wide with some of our minerals, so not just West Coast.
Yep.
That's our primary focus. Are there other deposits around the country that we could do some sort of chemical extraction on?
So will any of this be useful in, say, we know now that we've got significant garnet reserves on the coast. We've got ilmenite along the Barrytown Straits there and north of Westport.
Definitely. We're not just looking at gold. We want to look at, and we are looking at your ilmenites, your garnets, and your zircons.
What's zircon used for?
So zircon is a high temperature metal. It's used in a lot of the furnaces, and it's getting a lot more popular and a lot more in demand because it can go up to very, very high temperatures, and it's used in those sort of blast furnaces as an alloy.
And ilmenite, is that, I always understood that was something to do with paint. Was it?
Ilmenite is your titaniums. So there's a number of uses for ilmenite, but one of the key things you can do with it is extract the titanium from it. You all know titanium has many options.
Absolutely.
And garnet you use for your sandblasting, primary, and it's a great option because it's a natural mineral. It has all the properties that sandblasting is valuable for. So yeah, so here we have this a range of equipment, so we can support pretty much every single mineral that there is on the coast. And we've done some analysis, and there pretty much is every single mineral on the coast.
Isn't that incredible? What's this thing here?
This one here is called a Rodone. So this one here is similar to the crushers in the other room, but you would use this one to break up really big rocks. Again, working with the hard rock miners further inland, going, hey, what's inside of your rocks?
Yep.
And how much energy do you need to use to break it apart? Because you want to minimize the amount of energy to maximize the amount of valuable minerals.
Wow. Well, Thomas, this is, I've got to say, this is really exciting. I've been aware that you've been up here working for probably 2 years now. 3, is it? Close to 3.
The Institute for about 3 years.
Yeah. And it's my first visit, and coming and seeing what you're doing with the development of the laboratories, I mean, this is stunning stuff.
Thanks for coming in, and yeah, we're looking forward to getting some real results out there, and supporting the coast to get the message out there of what we can do and what the coast can offer to New Zealand.
Well, there we go, coasters. And Tom, it only needs one successful application of something, and this will be an absolute New Zealand winner.
Exactly.
Catch you later.
Thank you.